Hi everyone, and welcome to this lecture on how to report statistics using APA 7 formatting. So why is not only reporting statistics, but reporting statistics using a very standardized method such as APA formatting important? Well, first, it helps your readers to understand your methods and analysis. And two, it allows for reviewers to confirm your findings. Essentially, if everyone has their own way of reporting things, it's really hard to know what was done and what was found. And so having a way that is consistent across studies, across researchers, is very helpful for confirming research and replication and extension. And just know that as we go through, there are so many little formatting things with APA 7, and you do have a lot of resources available to you because this is a lot to memorize and know. We have the APA style websites and then a general rule guide on using numbers and statistics in APA 7 linked here. We have the ISU Writing Center, and there's also some additional links on Canvas as well. This page just shows you different statistical abbreviations and symbols. This is just for your own convenience, so you can really copy and paste each one as needed, as it's not really something you can find on your keyboard, and it can take a minute or two to search for using Word or Google Docs. Just some general rules for you. Know that all symbols that are not Greek letters should be italicized, so your means, your standard deviations, your F values, and so on. Any symbols that are Greek letters, like alpha or beta, are not italicized. Parentheses and numbers that come after the symbols should not be italicized unless you are stating the confidence interval. You should report means and standard deviations for data measured on an integer scale to 1 decimal. For example, if you have a survey and you total your responses using a number system and it totals to 12.578, you would just round and say 12.6. Make sure to report other means, standard deviations, correlations, and inferential statistics to 2 decimals. And then your p-values should be reported exactly. So if you have p equals 0.02, you would just say p equals 0.02. Not p is less than 0.05. There is an exception though if the p-value is less than 0.001, in which you would round to 3 decimals. For instance, if you have a p-value of 0.0004, you would report p is less than 0.001. Whether or not you put a 0 before your decimal depends on what is being measured. If the statistic can exceed 1, like means, standard deviations, or t-tests, which is the example on the slide, put a 0 before the decimal. But if the statistic cannot exceed 1, like with a Pearson R in which 1 is a perfect correlation and you can't go beyond that, do not put a 0 before it. You should have spaces before and after equal signs and inequality signs. And you can see that in this example, that m equals 34, where everything is all squished together, is incorrect. But m equals 34 with the spaces between it is correct. For negative values, put a space only before the minus sign, not after it. So it's not negative space 82, but negative 82. So how would we write up something like a one sample t-test? Which, as a reminder, is used to determine if the mean calculated from a sample is different than the known or specified value previously stated. And so if you're going to do this in APA formatting, there's a very specific process. First, you would state the sample mean, reporting the mean and standard deviation, whether or not it was significantly different from the population mean. And then if it was significant, you report the full results of that t-test. If it was not significant, you don't have to do that last piece right there. So for example, exam scores of students who used a new textbook, you have your stats, were significantly different from those of last semester students who used the old textbook. You have the population mean, and then because it was significant, you have the fully reported t-test right there. Looking at independent samples and between subjects t-tests, These tests are used to compare two samples from unrelated groups. This is used to determine if the samples are different from each other, if group 1 differs from group 2. Subjects belong to only one group and are only tested once. Writing this in APA, you would state your group 1 with a group mean and standard deviation, and whether or not they had significantly different scores on your dependent variable compared to group 2, with that group's mean and standard deviation. If it is significant, you report the full t-test, which I didn't mention this last time, but this includes the degrees of freedom, the t-value, the p-value, and then the effect size. If not, you don't need to worry about that part. The example here is students who studied in the morning with their mean and standard deviation had significantly higher final exam scores than students who studied at night with that group's mean and standard deviation. And because it was significant, the t-test is again reported. Talking about paired samples, repeated measures within subjects' t-tests, these tests are used to analyze the same subject on a continuous measure of two different occasions or under two different conditions or observations. And so this is going to follow a very similar pattern that you've seen with previous APA reporting on the previous slides. The example here shows study participants with how many cigarettes they smoked before and after hypnosis. And so reading this out loud, study participants showed a significant reduction in the number of cigarettes smoked. So right away, you're talking about the dependent variable there. After hypnosis, so that's the mean and standard deviation for the group afterwards compared to before hypnosis. And so this is the group's mean and standard deviation before that took place. So same people, but it's a before and after. And again, because it was significant, you report the full t-test. Looking at one factor independent between subjects and ANOVAs, these tests are used to analyze different subjects who are tested under one condition, and each subject is only tested once. When you go to write up these results in APA, you would say something along the lines of the one factor between subjects analysis of variance revealed a significant difference in your dependent variable across your independent variable or factors. And then you would report the full F test. With your F in parentheses, you have your degrees of freedom, you have your p-value, and then you have your effect size. So for example, the one factor between subjects analysis of variance revealed a significant difference in exam scores across the different learning styles. And again, because it was significant, that full F test is reported. What about the one factor repeated or within subjects ANOVA? And this is a little bit different because it's used to analyze the same subjects who were tested across different time periods or conditions. And each subject is tested 2 or more times. And so writing up these results in APA, you would say the one factor within subjects analysis of variance, being specific on what ANOVA you're running, revealed a significant difference in the dependent variable across the independent variable or factor. And then again, if it's significant, reporting that full F test. So for example, the one factor within subjects analysis of variance revealed a significant difference in job satisfaction ratings of workers on their first day of work and at a 2-month follow-up. So you can see that we are measuring the same people 2 or more times. And because it's significant, you have the F test. So what about a 2-factor ANOVA? What if you want to get really spicy with everything and have multiple independent variables and see how different things affect one dependent variable? The official terminology here is that a 2-factor ANOVA is used to analyze the main effect and interaction effects of multiple independent variables on the dependent variable. So for example, say you want to look at how much someone wants to buy a product, and not only how much someone wants to buy a product, but under what conditions with those commercials. Is the commercial soft? Is it loud? Is the individual familiar with the product? And so when you're going to report this, You might say something along the lines of, I conducted a 2 by 2 factorial ANOVA. And so with the first two, you would have the volume soft or loud, and then the two would be the product familiarity, and stating those out, with the intention to buy the product as the dependent variable. The omnibus or overall ANOVA revealed a significant main effect of volume, such that participants were more likely to buy the product when the commercial volume was loud. And then you have the mean and standard deviation of that group. Compared to when it was soft, again, the mean standard deviation of people who heard the soft commercial. Because it was significant, you have the F test. And then you would go on and say something like the ANOVA was also revealed to have a significant main effect of product familiarity, such that participants were more likely to buy the product when they were familiar with it, mean standard deviation, compared to when they were less familiar with it, mean standard deviation comparison for that independent variable as well. So you've compared both of these, and then you have to look at them together. So lastly, in line with my hypothesis, the ANOVA revealed a significant interaction. So people were not only buying the product when it was loud and they were familiar, but when it was both together, they were even more likely. And so, as you can see, this is a little bit more complicated. It's a little bit outside of the scope for this class, but you are likely to run into this when you're reading research. And if this is something that you are really wanting to do and you can find a way to do it with a survey, let's talk about it. Make sure that you have this down because it is, again, a little bit more advanced here. So let's dial it back a little bit and talk about correlations. As you know, correlations are used to describe the strength and direction of the linear relationship between two quantitative variables. So when you're writing up your results in APA, you would start with saying it was a Pearson correlation coefficient, be specific about what test you ran, was computed to assess the linear relationship between variable 1 and variable 2. There was a strength and whether or not it was negative or positive correlation between the two variables. And because it was significant, you're reporting the Pearson's R value. So R with your degrees of freedom in parentheses equals the R value. Make sure to include whether or not it was positive or negative, specifically if it's negative in this case, and then the p-value. So, for example, a Pearson correlation coefficient was computed to assess the linear relationship between self-esteem and happiness. There was a strong positive correlation between the two variables, and then writing out the R value. Lastly, we're going to talk about the chi-square tests. Specifically, we're going to talk about the goodness of fit test here, which is used to test how well the obtained sample proportions fit the known population proportions. So when you're going to write up your results in APA, if you're using a chi-square test, you would say a chi-square goodness of fit test, again, being specific with which test it is, was performed to assess whether the distribution of variables differed or did not differ from the expected or population distribution. The distribution of your variables did not differ or did differ from the expected distribution. You would have your chi-square, and then in parentheses, you would have your degrees of freedom, your sample size, and then equals the chi-square statistic value, followed by p or your p-value. So for example, a chi-square goodness of fit test was performed to assess whether the distribution of primary therapy modalities used by new therapists differed from the expected distribution of seasoned therapists. The distribution of primary therapist modalities did differ from the expected distribution of seasoned therapists. Chi-square with your degrees of freedom, your n, followed by the number that is your output and your p-value. Lastly, we have the chi-square test of independence, which is used to test whether there is a relationship between two nominal variables. When you're writing up your results in APA, again, you want to be specific with which test you ran. So this says a chi-square test of independence was performed to assess the relationship between variable 1 and variable 2. And then you state that Either there was or was not a significant difference between variable 1 and variable 2, followed by your chi-square with your degrees of freedom and sample size in parentheses, your chi-square statistic value, and then your p-value. And the example given here says a chi-square test of independence was performed to assess the relationship between training program and primary therapy modality in new therapists. There was a significant relationship between training program and primary therapy modality used in new therapists, followed by the chi-square statistics. And that's all I have for you. Thank you for listening, and I'll see you in the next APA lecture.